All right, on problem number 5 here, some horrible human being has added to your work that you have, and rather than giving you the empirical formula and the mass of the molecule, has given you information that you can calculate the empirical formula. And so you can go back and look at video number 4 if you need more help understanding this step. But if we pretend that this is a 100-gram sample, the percents becomes grams of whatever element that it is. Okay, going to go with my table now. Now it's carbon, hydrogen, and oxygen. Just going to transfer my data down here. Hopefully, 29.06. Okay, and these are masses in grams. Okay, of course, totaling back to 100 grams if we were to add them up. Now the molar mass in grams per mole from the periodic table. I have these memorized, so 12.01. Okay, that's just the number shortened to 2 decimal places from the periodic table. 1.08 for hydrogen and 16 for oxygen. So we got grams, we've got grams per mole. If I divide the grams by the grams per mole, I get moles. I get a mole ratio here. Okay, and now I have a proper ratio of moles. However, these are not integers. And I don't want to just take these, I do not want to round these to 5, 5, and 1.8 because that's a huge amount of rounding that we're doing actually. So what I want to do is go through and divide all of these by the smallest. And the smallest is this 1.81. That will make that one 1 for oxygen, and then 5.4496 divided by 1.8165 comes out really close to 3. These are about the same. I mean, I can put it in anyway. But it's going to be, yeah, this one's just a little bit smaller than 3. This one's just a little bit bigger than 3. So, but they're both very, very close to 3. And so this is our ratio. So our empirical formula then is C3H3O. 3 carbons, 3 hydrogens, and 1 oxygen. Well, now we need to go about figuring out what the molecular formula is. And I'll remind you, mass of the molecule is equal to some integer, some counting number x, times the mass of the empirical formula. Mass of the molecule is given, 110.10 is equal to x times this mass of this empirical formula, 3 times 12.01 plus 3 times 1.008 plus 1 times 16.00. Okay, 55.054 grams per mole is the mass of that empirical formula. 55.054. And so x is equal to 11010 divided by 55.05. So that's 2. So empirical formula was C3H3O. The molecular formula is twice as heavy though. So that means I need to double the amount of carbon, I need to double the amount of hydrogen, and I need to double the amount of oxygen.